afternoon, everyone. See some familiar faces from yesterday, some different. So I'll try not to assume that everyone was here yesterday. But if I say something that maybe doesn't make sense because I referenced it yesterday, feel free to call me out on it. I'm James. I just started my Solana development journey a couple months ago. So we're all kind of in the same boat here. I maybe just have a slight head start. My personal opinion on that is that it helps to sort of know what it's like to be getting going on things from starting. So I'm really excited about it. Regardless of what kind of developer you are, whether you're front end dev, back end dev, mobile dev, there's a spot in Solana for you. There's a bunch of different entry points in the ecosystem. This is just one of them. Yesterday, we spent a lot of time covering more front-end, client-side type stuff. Today, we'll be covering more smart contract type stuff, so doing things in Rust. It's a lot of fun, regardless of where you enter. But depending on where you're coming from, it may be a little bit unfamiliar, a little bit daunting. It doesn't have to be, and so we'll talk about that a bit. This is waiting for the screen to update. Love that. We had this problem yesterday, but the internet lags significantly, or does that, where it just drops the Zoom call entirely, and then brings it back. You go on hotspot. My hotspot is worse, so pretty much no. I also think a large part of it is the receiving side of things as well. So, okay, there we go. Back in. Let me set that away. Okay. So this is the main plan for today. We're going to do an overview of some of the basics of Solana program development. And then we're going to build out a program. So yesterday, if you were yesterday, we built out like this movie review application, a web application where you can submit a movie review, and then a Solana program that I already built sort of was taking care of the stuff in the back end. We're going to be building that back end piece today. So building the Solana program that backs this. And then I put here, depending on time, we could try to get a local development environment set up. If I'm being completely honest, I don't think we're going to get to that point. But if any of you have questions and need help setting up your local dev environment, please come by the Solana booth at some point, and we'll help you out. All right, some thoughts. I've written this to sort of assuming that you've never done any Solana development. That may not be true for everyone here. How many here have done some Solana development before? Okay, a couple of people, but most everyone is new to this. That's great. If you are experienced in this at all, please stick around, help the people out next to you, act like a TA of sorts. And then for those of you who are new, if this ever feels daunting, don't worry, you'll get there. Everything that's new feels out of place, and you'll figure it out, I promise. I did. If I can, you can. Also, I mentioned this yesterday, but for anyone who wasn't here, there's an open source course on soldev.app/course that we're writing. Right now, it's mostly client side. So the things we're covering today won't be in there right away, but they will be shortly. Within the next probably a month or so, we'll have some more program related stuff in the course. Feel free to check it out, and I'll have that link at the end as well for you. Now, while we build out the movie program, we're going to be, we've got like a client test thing to submit transactions. So I would download this right now while we're talking through some stuff. That way, when we're building out the movie program, we'll deploy it at various intervals, and you can use this client to submit transactions. It's just a Node.js script that you can run locally, and it'll just sort of submit stuff for you. So once you download it, you can do an npm install or a yarn install, whatever you use, and it should work. And we'll talk about it in a few, but I want to give you a chance to get the link, try to get it downloaded. So it's github.com/unbox-software/Solana-movie-client. All right. And you don't need to worry about what's in there exactly. It's just we're gonna do npm start, yarn start, and it'll fire off a transaction to the program that we're building, so that we can see what's happening at various intervals. Yeah.
It's share the slides as well.
The slides. I can. That will be challenging to do right away, but I can get them there afterward. If that's all right.
Yeah, we put it in the Discord, and also the link up there is now general chat.
You just drop it.
Activated or called Discord chat, general chat.
Awesome. Thank you, Carter. All right, so you can grab the link from the Discord there if you still need to grab that. So let's talk about Solana programs. So this is sort of general, idea of Solana network, right? Is you've got the network with all its nodes, and then you deploy programs, usually written in Rust, to the network directly, and then clients interact with the network through what's called the JSON RPC API. We dealt a lot with that bottom piece yesterday, talking about how the client interacts with the network, and we're going to talk more today about how programs are deployed to the network. Programs are typically written in Rust. You can write them in C and C++, but that's not quite as common. Rust is a little bit more modern and something that most people are using nowadays. Programs are deployed to accounts on the Solana network. Yesterday we talked about how Solana accounts are kind of like the file system of Solana. So you can kind of treat accounts as files and store data in them. The only difference about a program account is that account is marked as executable. Okay, so it's an account that stores this code that can be run when you submit a transaction to that program. Now, a couple of basic things about programs. They have a single entry point. So it's kind of like the main file or the main function of a program. Okay, so anytime a program gets called, it gets called through one single entry point. The entry point of that program provides you or your code with three things. The ID of the program, which is basically the address of the account that it's stored in, the list of accounts that will be read from or written to during the duration of the transaction, and any instruction data that's going along with that transaction. Okay, so go fast. Let's talk about that instruction data piece real fast. So instruction data is like the arguments or parameters to the function call for the program. Okay, so it's your job as the developer to write code inside the program that can decode the byte array, the instruction data byte array, into the requisite data. And we'll do that all together a little bit later. Any questions so far? All kind of high level. If you have any questions, we do that. We are going to dig into specifics later. Now, it's important to recognize you can't store data on the program itself. Okay, so any sort of state changes happen on external accounts that aren't the program itself. Okay, we call those accounts PDAs or program-derived addresses. Right. So there's a really cool thing here, which is typically when you derive an address for Solana, you're getting an address on this ED2559 elliptic curve. So this is a mathematical curve that basically anywhere you land on that curve, it has a corresponding point on the curve. Okay, and that's what gives you your public and your private keys. So you keep your keys private and use that to sign transactions, and you can expose your public key to sort of give people your identity, that sort of thing. Now, PDAs, what separates them from traditional addresses in Solana is that they fall off of this curve. Okay, so you don't actually create a PDA; you just find a PDA. You find, right? You derive a key that does not fall on this curve, and by doing so, you basically get a public key that doesn't have a corresponding private key. The reason this is important and/or excuse me. and/or cool is that you can't, from a security perspective, you literally cannot sign on behalf of an account. There is no private key with which to sign on behalf of the account, which means that the only way to sign, aka write data for PDA, is if you are the program yourself, right? Which is pretty neat. So it basically means that you can get a bunch of accounts within your program that only can be written to by your program. So you don't have any security risks with having other programs writing to that account. All right. Any questions about that, about the PDA derivation? Okay, we'll go through it a little bit later and have a concrete example. Quick couple of things to note about accounts. When you first initialize an account, so for example, you derive a PDA and you're going to initialize the account for that PDA so that you can store some data in it, kind of like creating a file so you can dump some data into that file. When you initialize it, you have to add enough LAN ports. LAN ports are fractional sol to be what's called rent exempt. So not too long ago, there was a concept in Solana called rent, where for you to have an account, you basically had to pay rent on that account for essentially the storage size that you were using. Very cheap, but it still existed. And if at any point in time you didn't have enough sol in that account to cover the rent, that account would be deallocated. Rent was recently done away with, or rather, they made it so that you have to front enough sol to make the account rent exempt. Okay, so rent exemption already existed, but recently they decided you just have to be rent exempt, which is great because nobody actually wanted to do the rent thing. They always just wanted to put enough sol up front to not have to pay rent down the line. So now you will be enforced to do that. You can't initialize an account without depositing enough sol to be rent exempt. The only reason I bring this up is that it is an important step in creating an account. And again, we'll go through a concrete example shortly, but I think it's important to sort of get 2 iterations of all these concepts. Any questions about rent? All right. Another thing about accounts, just like the instruction data that we said comes in as a byte array, all the data on your account is also stored as a byte array. Okay, so it's your job as a developer to figure out a layout of bytes that makes sense to store this data so that you can then retrieve it and decode it properly. And then lastly, when you're initializing an account, you have to decide an account size, and that size should be determined based on the size of the data you're gonna store there. So you can, make a larger size, have some extra padding, if you will, but you should take into account the size of the data that you're actually going to store and decide the size of that account accordingly.
Can I change it later?
Yeah.
Is it possible to change the size later?
As of just the other week, yes. We're not going to cover that today, but yes. Hey, Don, do you know they just released the resizing of accounts just the other week, right? Yeah. That's live. What's that?
Yeah, it's just being implemented.
Oh, so it's not quite out yet.
It is out, but
okay, so it's kind of out.
Make it easier to see.
Okay, cool. So it's out, but probably don't bank on it right this second. Maybe wait for better implementations. Is that what I heard from you?
Anyone that wants to accept the challenge?
Right. So it's difficult to do right now, is what I'm saying. So you can do it. It's difficult. It will be easier in the next couple of months. Cool. All right. So let's talk quickly about Borsch. Borsch is the way that we serialize data. You don't have to serialize data this way, but this is kind of the customary formatting, if you will, that people have sort of adopted on Solana. So you can go to borsch.io and look at the specifications for how data is laid out in a byte array when you use Borsch, or you can just use the Borsch libraries, okay, which are called crates in Rust. Anyone in here know any Rust? Anyone here use Rust at all? We got one hand raised, and we got a bunch of kinda, sorta, maybe. I'm also in the kind of sort of maybe camp. So again, we're all in this together. It's okay. Rust is actually really, really awesome. Has a bunch of really neat features. I think it has some challenging syntax, I think, for people to pick up on when they're coming from other languages. But the people who really get a hang of Rust just can't stop talking about it and love it. So maybe you guys will too. All right. Any questions before we dive into some examples? Okay. So what we're going to do is we're going to start building some stuff. And we'll kind of just get as far as we can in building this project. I've got a couple of checkpoints in this movie review project where we'll be able to deploy the program, submit a transaction from that test client that I asked you guys to download, and sort of see some logs and see that things are actually happening. We probably won't finish building the entire program today. So hence the checkpoints is a way to sort of see a couple of points of progress, even though we won't get all the way to the end. Cool? Everybody downloaded that test client? Okay, let's walk through that real fast just to see what it looks like, what it is. So if you downloaded the test client, this is what it looks like in VS Code here. It's basically just everything in this index.ts file. It's just a script that basically initializes a key pair, or creates a key pair if you don't already have one. It will airdrop you some Sol on DevNet if you have a new key pair that doesn't have one. And then it creates a transaction. It's everything we did yesterday with the movie review transaction yesterday. It just does all that and submits a transaction to DevNet for you. What you're going to need to do at some point is on line 94, you'll see this const movie program ID right here. You'll need to replace this with your program. So when we get to the point where we're deploying a program, I will show you where your program ID is, and you'll need to replace this with your own. Got it? Okay, so I'll make that clear to begin with. To run this, you're just going to open your console, make sure you're in the right directory, and you're either going to do npm start or yarn start. You'll need to install your dependencies first. Okay, so whatever dependency management tool you have, npm or yarn, use that to install your packages first, and then you can do npm start or yarn start. Okay. The very first, there's a weird bug with it that I haven't had time to figure out which is the very first time you run it, it will fail on you. Doesn't mean everything is lost. Okay, it'll try to submit a transaction and it won't be able to because your account won't have any Sol yet. If you give it a few seconds and then try again, the airdrop that I said it requests will have completed. Your account will have Sol in it, and you will be able to submit transactions. Cool. It may even be worth just doing that now, just doing a quick npm start to get that failure out of the way, so that later when we actually try to test, it works. Okay. What was that? No, it's on DevNet. Yeah, this is all on DevNet. No Sol that's actually worth anything. You can't just request airdrops for free stuff on mainnet, unfortunately. You could try to sell your DevNet Sol, but I don't think you'll have a lot of luck with that. Okay, cool. With that, I need everybody to open up your browser. Safari doesn't seem to work with this, but Chrome does. So I'm going to open up my browser and I'm going to go to beta.solpg.io. That's beta.solpg.io. This is the IDE that we're going to use today. Okay. If we started with, let's all get our local development environment ready for Solana, we might be here for the next couple hours and not actually build anything. Because everyone's machine is set up slightly just a little bit differently. We'd be trying to hack together different things with path variables like Karthik and I were talking about earlier, and it just may or may not work. So what we're going to do is just stick with this, okay? Does everybody have this open? Yeah? Okay, so this is actually really cool. It's Solana Playground is the idea. So you can actually just build your project in here, and you can deploy to DevNet and mainnet actually, but you can deploy directly from here, right? So the first thing I want you to do is down at the bottom left here, there's this not connected bit. I want you to click that, and it's just going to create a new wallet for you if you just hit continue. It's just going to create a new wallet for you. Again, just a testing wallet. Don't put any real stuff into this wallet. That's not very smart. And you'll just have this wallet in your browser so that it can do stuff on DevNet for you. Cool? It's really a nice learning tool, so you don't have to deal with the overhead of getting this stuff set up on your machine. Next thing I want you to do is just clear out everything that's written in there. Like clear out all the boilerplate. We're going to start from scratch. All good? Okay. Let's get started with the code. The most exciting part. Okay, so a lot of the things that we're going to do with Rust today are very similar to other languages. Who in here? Oh, come on. Second, I'll bring Zoom back up. Back. All right. So who here knows JavaScript at all? Got a decent JavaScript. What else do we got? Python. Okay, that covers most everybody. So we're pretty good with just JavaScript and Python. That's great. That's perfect. So modern languages that work. You've got import statements in JavaScript. I don't know enough Python. I don't know what you got with Python. Same thing. Also import, right? So the equivalent for that in Rust is going to be a use statement. So we're going to say use, and then we're going to import this. Let's make this a little bigger, sorry, so we can actually see what's going on. That makes this a lot smaller. I don't know that. Oh, well. All right, so we're going to use Solana_program, and then 2 colons, and then curly braces. Okay. So what this Rust's libraries, if you will, are called crates. Okay. And within each crate are a bunch of modules, and you kind of have to go through and import all the things that you want to use in this way. So we're starting with the highest level library, Solana program, and then we're going to go in and we're going to pull out a bunch of modules that we're going to use. Okay, so we're going to use account info, account_info, and then account info like that. Can you guys read this? Do you need it bigger still? Does anyone need this bigger? Okay, good. All right, we're going to do that. We're going to do comma. We're going to add entry point, comma, entry point, double colon, program result, and then pub key, double colon, pub key. That double colon is a way of basically traversing modules. So you have nested modules, and that double colon is a way of saying go to the child module. There may be other uses for it, but that's the one that's, I think, most common that I see most. By the way, for those of you in here that know Rust, if I say anything that is technically inaccurate, you're welcome to call me out on it. I don't consider myself enough of an expert in Rust to say that it's the only way or whatever. But this will work, and then make sure you get a semicolon there at the end. And those are all the things that we're going to start with to build our, we're going to start with like a hello world type program, and then slowly build it out to the movie review program that we're working with. Does anybody need me to stop before we move on? Are we good? All right, let's keep going on. Feel free to slow me down if you ever need me to slow down.
How did it compile?
What was that?
Just go to compile.
You want me to compile it? That you said? So we're gonna get a bunch of warnings because we're not using any of the things that we've imported yet, but it does technically compile. Okay. So next thing we're gonna do, let's talk about this entry point piece. Remember I said that there's a single entry point into a Solana program. The Solana program crate comes with this entry point macro. A macro in Rust is basically like meta programming. Okay, we'll take something you give it and write more code to deal with that. So we're going to use the entry point macro right here, and we need to pass it a function that handles the inputs that we talked about the entry point having. So underneath this, we're going to add pub fn process underscore instruction. And this is us just defining a new function. Okay. Now inside the parentheses, we're going to add some parameters. We're going to add program ID. We're going to add accounts. And we're going to add instruction data. Okay. Notice I put an underscore before every one of these. That just tells the compiler, I know I'm not using these yet. Don't give me the compiler warning that these are unused variables. Okay, so we'll get rid of those once we actually start using these parameters, but for now, silence is some compiler warnings. It's a beautiful thing. The type of program ID is this ampersand pub key. The type of accounts is an account info array, again with that ampersand before it. And then instruction data is a byte array or an unsigned 8-bit integer array. Okay. Forgot one thing in the definition of this, which is that I need to return a program result. So right there on line 14, just tack on that arrow with the program result. And inside the function, we're going to return that program result, which is just OK, with empty parentheses inside of it. Yeah.
What does it mean to return a program result? Is a program result specifically to Solana?
Yes. So well.
Result is?
Yes, it's an enum that's specific to Solana that basically says this succeeded or it failed. Okay. So I just put the success result in there. Okay. And that's it for now. Now I'm going to come up here to entry point and pass in that function name. So this basically says what this is doing on line 8 is saying, hey, Solana, the entry point to this program is going to be this process instruction function. Okay. If we build now, it compiles and finishes just fine, no errors. Okay. Now, if we were to change the parameters inside process instruction to where they didn't have the appropriate types, we would have some compiler errors. Okay, so the entry point does enforce that we have the right types and that we're doing the right thing. All good so far? Okay, so like I said, this builds, but it doesn't really do anything. So let's just add one more thing that's iconic for most things, and let's just add a hello world on line 15. To do that, we're also going to have to add message on line 6, because that's a separate macro that we have to pull in. Should have led with that. Sorry. At this point, should be able to build. Oh, I forgot a semicolon here, so I can't build. There we go. Semicolon on line 16. Should be able to build. How long it takes will depend on my internet connection. manageable for you. This one's taking quite a bit. It's got me concerned about my internet. Okay, so that finished. So now what I'm going to do is I've got a program that builds and prints hello world to a console, and that's great. So let's go ahead and deploy. I'm just going to click this deploy button. It says deploying. This could take a while depending on the program size and network conditions. The program size here is tiny, so it depends almost entirely on network conditions. So we will stick to the bare minimum amount of deploying programs. But I would go ahead and deploy your program. So if yours is building, I'd go ahead and click deploy. There we go, mine's almost done. Deployment successful. All right, it says deployment successful. Now, if you click this extra button right here, you get a drop down, one of which says program credentials. If you do a drop down for program credentials, you'll see your program ID right here, and you can click the copy button right next to it. We're going to go back to the test client that you downloaded and replace the movie program ID with the ID that you have right there. Okay? Then you're going to hit save. And then if you run this client again, take a minute, but it will submit a transaction for us. And once it's successfully completed that transaction, it will put this Solana Explorer link in the console for you, which is a link to that transaction on Solana Explorer. So if you put that, it'll take you to Solana Explorer. You'll see that it was a successful transaction. And if you scroll to the bottom, you can see the logs, and you'll see the very first log is hello world. And there you go.
If you go back to the point where you were airdrop yourself.
This one?
From my is the address that was deployed.
Sorry, I can't hear. There's like
program ID is the address where it's going to deploy. Right?
Yes. Yeah, this program ID right here is just the address where the program is deployed. That is correct.
What do you think here? Is this new, or how do it solve this program?
Yeah, so the Solana program here has taken care of all the boilerplate stuff, all the setup stuff, right? So if you were to deploy a program to mainnet, you would have to provide some actual SOL for this to work. But since this is DevNet and this is Solana Playground, it just airdropped you some of that lovely fake DevNet SOL and made it work. Cool. Did everybody get this working?
Not yet.
Not yet?
I changed a line, and I can see that during the calculation, it kind of doesn't see the change.
Okay, let me check my
Should
load. I want us all to get this working before we move on.
That's your point. You just added process function, but it's
Oh yeah, that's weird. Why it's not? I honestly don't know what I just did there. I just tricked it.
magic.
In the message, sent on chain. That's the log.
What was that?
The log message is on chain.
Yeah, so the log message here. Yes, this is on chain. So every time we submit that transaction with the test client, we're gonna go look at the logs on Solana Explorer, because these logs are coming straight from what's on chain. So this is what's actually on DevNet. So if you got this working, then you just deployed potentially your first Solana program, which is awesome. Congratulations. Big round of applause for Let's take 3 minutes and make sure everyone got this. Turn to your neighbors, make sure your neighbors, well, maybe not 3 minutes, depends on what we need. Does anyone not have this working? I want to come help out. Does anyone now have this working? Yeah, let's get this working. Turn to your neighbors, help everyone out. Let's get this working for everyone. Anybody else need some help get across the finish line? Good? Got it? Got it? You good here? Yeah, you got yours? Got it working? All good? Yours working? Awesome. You guys good? All good over here? Yeah. All good? Good? Yes. Okay. Give me like 20 more seconds, guys. Okay, let's continue onward. All right, let's keep going with this, guys. So we got a program that works, and that's awesome. We can do better, so we're gonna do better. We're gonna keep going with this. Okay, so we're gonna move on, and we're gonna talk about instruction matching. So what do I mean by instruction matching? Let's talk about it. Who was here yesterday? You got a few people who were here yesterday. You guys remember how we talked about the instruction data and how oftentimes the very first byte of your instruction data will be some kind of identifier that basically points to, represents the function on the program that you want to call, right? So in this scenario, it's probably good to implement something like that from the beginning. So what do I mean? Well, since there's only one entry point into your program, you might have the instruction data. That first byte could be an integer, or you could have the first few bytes be a string identifier, whatever you want. That basically says this is the instruction I want you to perform. So in this scenario, we're making a program that's adding a movie review to an account. What later we might also have delete movie review or update movie review, right? And so it'd be good for that first byte in our instruction data to represent which function we're going to perform. Okay, so what we're going to do is we're just going to add an integer. We're just going to pretend that there's an integer at the beginning that represents that, and we're going to build our program accordingly. So the first thing I want you to do is create a new file. You did that in the Explorer here with this button at the top left. You hover over, it'll say new file. We're going to say instruction.rs. Similar to before, we're going to start this file with some use statements. Only this time, we only have to bring in program error to start, I think. And then we'll worry about some of the others later. Okay? Once we do that, what we're going to do is we're going to create an enum to represent the different instruction types. For now, we're only going to have one, but we're going to say pub enum movie instruction. Add movie review is going to be our only instruction type for now. So this is just the Rust declaration for enum. Okay, and then virtually all types in Rust, when you want to fill out any kind of implementation, things like functions, that sort of thing, you do that with the following: IMPL, and then the name of your type. So inside the implementation, we're going to put a function that basically will take the instruction data and determine which instruction type we're using. Okay, so we're going to create a function here called unpack that takes input, that input being an unsigned 8-bit integer array, an array of unsigned 8-bit integers, and returns a result enum with generic types self and program error. How many of you feel like really good about using types like this? A couple. How many of you are like, what the heck are types? Some. So, yeah. What's up?
Yeah, I think so. In this unpack function, you're returning results, which is enum in Rust.
Yeah.
But what is the difference between that result return type? Seems like that's a Rust native type versus program result is a Solana.
Correct. This is a Rust native result type. So this is a native type that basically it's kind of like, it's basically an enum, right? Where you have a success case and you have an error case. If it's the success case, then it's of type self, which here is movie instruction. And then if it's the error case, then you'll get a program error, which is a Solana type.
And then what is the difference between that and program results? Or why I use program results instead of just results?
Program result is just typed specifically for Solana. So that's what that function is expecting. So in this case, we're writing this function, we're writing entirely for ourselves. We have no external dependencies, if you will, that are, right? We could call this whatever we wanted, we could return whatever we wanted, and we just have to write our code to match. In the case here of process instruction and entry point requires that we return a program result. Okay, so we don't have options here with the definition of our return type here. This is what entry point requires. That makes sense? Awesome. Okay, let's jump back into here and let's implement this movie instruction. Okay. So here's what we're going to do. This is where things start to get fun. We're going to define this tuple where we take input and we call the function split first. And then we say okay, or I'll tell you what that means in just a second. I'm going to break these up into multiple lines for readability. So let me tell you what's happening here. The split first function is an array function that basically takes the first item and puts it into the first item in the tuple. So it'll take the first element of input and make that tag. And it'll take everything else in the array and put that into rest right here. Right? And then okay or is an error handling function that basically says if this function throws an error, this is what to do if we get an error. Okay? So this OK or says if it doesn't throw an error, then we're good. The first element goes to tag, everything else goes to rest. And then if we do throw an error, then we want to throw this error from our function. Okay? Make sense?
What does the question mark mean?
Don, you want to help me out here? The question mark here on 13, is that signifying to Rust that this could be optional? What's
It's to help handle error state in the graph. So
okay?
automatically turn.
Oh, it'll automatically return if there's an error.
Right. It's to help graph you OK or.
Got it. Listen. So yeah, so it's part of the OK order where it basically ends execution of this function if we have that if we have the error, but it does so in a way that doesn't panic. So if this, I think, if that were an exclamation mark and we got an error, then our entire program would terminate with a panic code, as opposed to returning the error from the function. Does that make sense? There's a lot of intricacies in Rust that, like, I feel okay with Rust, but there's a lot of intricacies still that, like, there's just a lot to learn. Cool. Any other questions about that? All right. So we've got our tag and rest. Notice I put an underscore next to rest because I'm just going to ignore it for now. We'll come back to it. And then what I'm going to do is, again, result. You have a success case, which is OK, and then you have an error case. So since we made it past this point, we're going to say OK as in we succeeded, lowercase k. I make that throw a lot. And then we're going to do a match on the tag. And match is like a switch case. Okay, so match is like switch in JavaScript or other type languages, or TypeScript or other type languages. And then we're going to say if it's a 0, then we're going to return a movie instruction of type add movie review. Otherwise, we're going to return an error of invalid instruction data. What this is saying is if we get a transaction that gives us a 1 as the very first byte of the instruction data, we're saying, hey, this program is not yet capable of handling that. We only have one type right now, and it's 0. So in the future, if you were to add functionality for deleting a movie or updating a movie review, then you would add cases to the movie instruction, right? So you'd add something like update movie review. And then you could switch, add the 1 to the matching here. That make sense? I'm not gonna actually do that right now, but that's how you go about that. Yes, sir.
So what would happen if you don't have that program error?
You would basically accept. You basically would accept everything. Only the compiler would force you to return either an error or a movie instruction. That make sense? So in this scenario, because it's a strongly typed language, you would be forced to either do an error or a movie instruction. So you either have to add a different movie instruction type or just return and add movie review every time.
So you just have to be more case specific.
Yeah. Yeah. So if you aren't super familiar with strongly typed languages, Rust is a very strongly typed language, very highly enforced type safety. It will make you do what you said you're going to do, which is I can only return a movie instruction or a program error. Cool. All right. So here's what we're going to do. We're going to go back into lib.rs. We're going to add to the top here pub mod instruction and use crate instruction movie instruction. That's how we're going to import essentially what we just did in instruction.rs. then what I'm going to do, so that we don't make process instruction really huge, is I'm going to make another function called add movie review, where we're going to pass the program ID and accounts, and we'll pass some more stuff in just a bit, but for now we'll just stick with that. And return the program result there. And now I'm going to move, instead of doing hello world like we did above, I'm going to put a different message. I'm going to say adding movie review. And then here where we did our OK and hello world on line 19 and 20, I'm going to get rid of those and say let instruction equal movie instruction, unpack, pass it instruction data. I'm going to remove the underscore from instruction data so that the compiler no longer ignores it. And then I'm going to do another match on instruction type where I say movie instruction, add movie review. If we have an add movie review, we're going to call add movie review and pass in the program ID and accounts. And again, I'm going to remove the underscores from those. Okay, let's talk about this real fast because that was a lot quickly. I basically just created a separate function that will handle adding the movie reviews. Right now, it just logs adding movie review. But when we add the actual functionality for doing the thing, that's where we're going to put it. And then in process instruction, I said, okay, we're gonna call movie instruction unpack function. We're gonna pass it the instruction data, and it's going to return either the movie instruction or an error. And the question mark says if it returns an error, then propagate that error through. Return that error from this function as well, right? And if it were an exclamation mark, we'd say if it returns an error, let's panic. And then we're going to match on that instruction. I don't know why this got a little jacked up here, spacing wise. We're going to match on that instruction and call add movie review. All good there? Any questions about that? Yeah.
On the instructions, can you go to the instruction
Yeah.
on the OK result and on the matcher? Would they have to be at the same time?
So result is a generic type. Okay, a result is a generic type that has two different types allowed. It is allowed a self, which in this case is movie instruction. So you can return a movie instruction or a program error. It will allow either.
Okay,
The reason it can do that is that result itself wraps basically a tuple where there's a tuple case for we have a success case. Sorry, not a tuple, an enum. Result is an enum where there's a success case and an error case. And in the success case, it will have a movie instruction, and in an error case, it will have a program error. We can dive into how this is implemented after this, if you want, because it is pretty cool. I remember when I first did something similar with Swift back in the day, and it was like fun, right? Any other questions? What was that?
Go back on the link that I
Yeah. So there's something specific you want to see? So while you're looking at that, I'm going to go ahead and build this to see if we're good, see if I made some typos, which apparently I did.
Is this a floor?
What's that?
It's a floor.
A few typos. Yeah, a few typos. Probably a lot of typos. So lots of missing semicolons for me. That's something you'll see a lot of from me. It's missing semicolons all the time. This one. See what else we got. Lib 21. Instruction, add movie review. Oh, so many typos.
Could you please scroll this one? Yeah. More. Thank you.
All the way down.
Yeah, that's it.
Okay.
Oh, you have an extra parenthesis on 24.
24. Thank you. It's not that. I'm a big fan of type languages, and this is why. Mismatched types. 21. So movie instruction, add movie review.
Well, and process instruction, you're not returning. Okay. Oh, but I guess add movie review.
Add movie review 27.
But then that's
Oh, okay, down there. Whoops.
okay.
Yep, there we go. Okay, that should be the last of it. There we go. Got it working. If you got a bunch of errors like that, just go through them one by one.
Could you
Hopefully, like me, it's mostly semicolons and then the occasional, not that. Yes,
Yes,
sir.
scroll, please.
Yes, let me. There you go. Any specific questions? There's something specific I can help you with. I'm going to go ahead and click the upgrade button here. So what that does is it upgrades the program that I've already deployed. Basically deploys the new code. Okay? It doesn't change the program ID. It just replaces it at the existing program ID. So now if I go run this again. Whoops. I'll let that run and come back to it. You still need to see this?
So the line 32, okay with two sets of parentheses. Why is that?
Yeah, because that's how program result is defined. So if you were to look at the type definition of program result, I don't actually know how to write it. My mind wants to write it in Swift, iOS developer background. So if I were to write it in Swift, it would look something like this. It would look like result program error, where result requires you to give it a success type, and so the success type is void, which basically means no return. Okay, so which means every time you call it, you have to give it an empty parentheses. Now if I go back to that test client and go into the Solana Explorer for the transaction and scroll down, sure enough, instead of saying hello world, it now says adding movie review, which is good. That's good progress. It means that things are working. Okay. Are we good to move on? Does anyone need to look at more code? Do I need to come help with anything specific? We good? Okay, I'm gonna move on. So the next thing I'm going to do here is I'm just going to add some test details to the movie, review. So I'm going to go back into instruction, and what you can actually do is in the add movie review enum, you can add properties to it by just right after the enum case, putting the curly braces and saying you want a title of type string, you want a rating of type U8, and we want a description of type string. All right? And then we go down here on line 20, this matching, where we're matching the tag to a movie instruction. Where we match it to add movie review, we also have to open up curly braces and we have to give it actual values. So for now, I'm just going to say title is test movie. And then afterwards, you have to say _string. The reason for that is test string, the literal, is of a different type than what we want, which is string a struct type. And then we need to add rating, and I'm just going to say 5 for testing. And then description, just a test. It's a string. Okay. Now the reason we're adding this is because we want to decode the instructions that come along with it, right? At some point, we want to decode those instructions into this data. So I'm going to go back into lib.rs and where we call add movie review, or where we define it. I'm going to add some stuff to this. I'm going to add title of type string. I'm going to add rating of type U8, and I'm going to add description of type string. And I'm going to add some additional logs. And you can add whatever logs make sense for you. But for me personally, I'm going to add logs for each property. So title, and then you have an open and close brace, curly brace for string interpolation. I'm going to add rating. And I'm going to add the description. Okay. And then when we call add movie review up here on line 21 and 22, this instruction matching, we actually have to, the compiler will force us to do this. So if we build, it'll get mad at us and it'll say a lot of things apparently. But it'll basically say that it expected a bunch of stuff. It's getting mad at me in instruction. I'll come back to the instruction. It's missing field description, rating, and title on in lib right here. So if you come here to line 2021, you have to add this. You have to add title, rating, and description. And those are accessible within the matching block. So we can pass them to the review, to the add movie review function. Just like that. I'll build and see what my errors are. Unexpected closing delimiter on lib rs25. So I forgot to have an extra parentheses that I shouldn't have. And then in instruction on line 23, I did not put a comment here. And there you go. So now it builds. Okay, we're getting close enough here to the end time-wise that I'm gonna speed up just a bit. So if you don't follow along, that's okay. You can stick around after in there, like if you want help getting things working, happy to do that. Okay. But for the sake of sort of seeing more of what you can do, I'm just going to kind of go through a little quicker. Still going to talk through it. Still ask questions if you have them. But let's be more conceptual in terms of what you're trying to get out of this, and less specific syntactical get working. Okay. All right. So at this point, If I build, it builds. I can upgrade. And then if I go test once it's fully upgraded, what should we see in the logs now? Before we saw adding movie review ... What should we see now in the logs?
Results.
What's that?
Results.
The new messages.
We should see the new messages, which were what? We kept the adding movie review, but then we also added the title, and it's a mock title that we hard coded, but the title, the rating, and the description. So when I click on this, the way I'll know if it worked is if I scroll down, I should see those. And sure enough, I see title, test movie, rating, 5, description, still just a test. Okay, so we're making incremental progress toward what we're going for. So now what we want to do is we want to move away from test data that I hard coded and get the actual data in there. Okay, the actual transaction data. So let's go ahead and do that. This is where things get wild. In a good way, always in a good way. So what we're going to do is we're going to add a couple things to our use statements up here. We're going to add Porsche, try from slice unchecked, and get instance packed length. Now I want to call out real fast before we start using this that we're doing some low-level stuff that we probably wouldn't normally do because of the online IDE that we're in. Okay, there is a set. So this is a Borsch module within the Solana program crate, but there's a separate Borsch crate that this online IDE doesn't yet support. I'm going to send me a message right after this, and we're going to get that sorted so that it will be supported next time I do this. But that would make it a lot easier. So some of what we're going to do right now is like kind of digging in deeper than you would normally have to. Normally, you could define a struct that matches the payload of the instruction and just use the crate, the Borsch crate, to kind of automatically make it work. Instead, what we're going to do is, in the same way that we pulled out the tag using split first, we're going to do some similar stuff here, where we're going to say let title equal try from slice unchecked, and we want a string as a result. And we're going to pass rest, and we need to unwrap it. Then we need to get the length of title. So I'm going to say title length equals get instance packed length of title. Yeah. The reason we need to get the length of title is we have an array of stuff, right? We have rest, which was our instruction data minus the first byte. Okay, we got the title out of it right here on line 19. Now we need to take rest and cut off the length of title because we already got that. We need to get rid of that so that we can then decode the next chunk of things. Okay, so we get the title length. Then we're going to say let data without title. We're going to basically slice it off by saying rest.get title length through rest.length unwrap. So this is going to return us a new byte array that doesn't have from the beginning of the array to where title ends. That way we can focus on the next piece of things. Okay, so we're going to say we'll do the same thing we did on line 16. We're going to call it rating and rest, not rest, you can call it rest. Description data works equals data without title. Dot split first. Okay, or program error, invalid instruction data. Okay, And then the last thing we're going to do, I know this is a lot, we're going to say let description equal try from slice, unchecked, description data dot unwrap. Oh, yes, dot unwrap. All right. Now we should be able to replace this title with the actual title, the rating with the actual rating, and the hard-coded description with the actual description. I probably have some typos. I do. Usually gives us a lot more than we need. Found keyword let expected colon on line 21. 21 colon. Missing colons everywhere. Semicolons, I mean.
Yeah, I think you need it on 22 because you're not the page for it.
Oh, you're right, you're right. Thank you for that. Cannot find value rest in this scope. Oh, I commented out rest. Expected value talking about program error. Line 23, I forgot a colon. There we go. Okay. Took care of my typos. Now I'm going to upgrade. So now when I test, what should I see? The real data that we sent in the logs. So let's go real fast and look at what that's going to be in the test client. If you go to line 39 and 40 in the test client, you'll see exactly what we encode and send into the instruction. We send variant as 0, so that's what is telling us to do the add move review function, enum type. And then the title is I did Braveheart and then appended a random number to it. The reason for that is that if I create the same account twice in a row, I'll get an error. Just because I wasn't planning on us getting that far where we handle that gracefully. So I just do a different title every time. A rating of 5 and a great movie. Let's change the rating to 4 because my hard-coded version was 5. So let's just change that so that we can see that it actually worked. It's still deploying, which tells me something happened with the internet. It has me concerned, to say the least. Could be a sole BG error. Not 100% certain. I'm gonna build it all over. I'm gonna build it again and try to upgrade again. Seems to be working this time, hopefully. Sorry about that. Internet problems just at the end. Made it almost all the way through without that being an issue. So we're getting to the end on time. So what I'll do is, if you want to see this, if you want to work through more of this with me afterward, I'll hang out in there for a bit. There's, I think, shortly after this, there's another workshop in here. I don't want to delay that. The next step we would have taken here is once we had the actual data, we would have gone ahead and created the PDA, the account to actually store the data into, and we would have effectively re-serialized the data as in the format that we wanted to store it in the account. Right? It's pretty cool stuff. It like everything that you haven't done before, it feels a little bit out there. It feels a little bit daunting. But even just after doing it a couple of times, it feels a lot more second nature. Start to understand it a lot more, and it's honestly not that big a deal. And you kind of can start to get creative with what you're working on. Yeah, this doesn't seem to be working from the internet standpoint, so I'm going to let that slide. In the meantime, thanks so much for coming today. If you want, this is the link to that course. We'll keep adding content to it over time. If you want to see the front end for this program, there's a link to the repo for the front end of this, so you can take the program that you're building and drop in the program ID into the front end code, and sort of see if you're working with the entire front end piece. And then if you ever have questions when I'm not here, which I won't be here after today, hit me up on Twitter. I'd love to connect with any of you. I'm usually pretty available there, and happy to connect with anyone. But thanks guys for being here. Have a good hackathon. What was that? Probably not yet. It's exactly what the next workout is, but check the schedule. What's up? Yeah. Thanks. Yeah, of course. I'll forward to you. Give me a second. Yeah. So this is right on Solana program on Solana. I did do it today. So
sorry that I called you from your phone freaking out, but.
Oh, sorry.
Oh.
Yeah. Yeah.
Should be able to usually
Yeah, you're right. Just come here.
Thank you so much.
So I like so they figure out
This is in your workshop.
yeah. Right, interest. Oh,
Okay, everyone. Hello, guys. My name is Dwayne Orchard. Are you guys ready? Yes, everyone ready here? Ready. Ready? So, hi, everyone. My name is Dwayne Orchard. I work I'm for the Devo team for Pagoda. I'm also the host of Blockhead. Pagoda is also a subset of Near, by the way. So, you're here Pagoda. So, I work for Pagoda / Near. I'm also the host of web series called Blockhead. Web series that shows on here. There's a community interviews, and also we host a new thing called Near Reviews. So I'll expose that to you about what's going on in years. Fun fact. Can you hear me? To the back. Yeah. So yeah. So fun fact about me again. Fun fact me is I live in San Francisco and we play rugby. So I guess we'll all be together. Exactly. Sorry about that. So the agenda for today, again, I'm talking building on top of Near. So we're going to be setting up, covering how to integrate Near into your application. So setting up your Near development environment. So the agenda will be resources to spin up a new application available for use. You can spin up an application quickly. Fundamentals of Near integrations, like a checklist I created that goes over everything you need to implement Near into your application, to your front-end application. And then we'll be also covering quickly how to write and integrate a Rust smart contract. So let's get started. So there are great ways to start your development environment. You can head on over to Near.dev to find some useful examples there. Near.dev. So in Near.dev, you can find examples for NFT, guestbook, counter. All these come with like their own GitHub repo, which you can clone. So you can have like a smart contract like written out for you, which is pretty useful. And they also, each of them come with like a unique front end as well. This is linked to the near examples repo, so you can find plenty of examples there, including our NFT tutorial, which is a fully fleshed out smart contract for minting and creating an NFT marketplace on top of here. This follows our standards that you can find on nomicon.io, so I can cover that resource later on if you guys are more interested in creating an NFT marketplace. But let's see. Another way to quickly spin up an application is the use of Create New App. In the future, we'll be having having a tool that'll appear on Developer Console in Developer Console hosted by Pagoda. So go to console.pagoda.co, log in. This is going to be an all-in-one place, all-in-one development environment to give developers all the tools they need in one location to build on here. You can look at recent transactions on smart contracts, add multiple smart contracts, get analytics about your project, soon get deployment information and alerts, and it also features API pair that like interact with test and maintenance. So just want to put this resource out there. We're still updating it, but in the future, again, it'll include a starter template for projects. But for now, you can still use Create New App in the meantime. Everyone can just span it up. If you spin it up typically, you would run something like npx create new app npx if you have no create new app -- contract. I'm saying like contract to Rust. And I'll just cover smart contracts in a bit too, so that you don't get too confused. And you're going to set the front end to React, so they'll fill out a template for React with the React framework. We also can use Vanilla.js as well. And then you just type in the name of your project, so name. So I don't want to like run that right now. I already ran it earlier for you guys, so you can see like the same one time. So let's see. So I have this example called CNA example. That is what I'm going to see as project name. It comes with It comes with a starter smart contract, all the most common traits you'll find in developing a Rust smart contract, as well as an example for implementing a change method and new method, which I'll also cover in a bit. So yeah, it's just like a neat little tidy place to kind of get you started on your development environment. So, it also comes with kind of the smart contract now, and once that loads, it'll like spin up a local server to show you guys the front end that's also included. So it sets you up to be able to develop or to automatically like, just get started on designing your application. You don't have to worry about like integrating the front end components. While it's loading, you can see there's like plenty of files here, and essentially for this workshop, I'll be kind of like going over like how you can set this up on your own, so you can better understand like what goes into each of these files located in the source folder for implementing your API.js. So here's the small demo application that comes with creating your app upon like installing that package. So let's see. So yeah, moving on. So here's like the fundamental checklist for installing your API.js, which again is the library used to integrate to connect your JavaScript application to the Near blockchain. So the first thing you need to create is an object, a configuration object, which will define your network, your key store, which node you're connecting to, the helper URL, and more. So I'll cover that in a bit. So I'm just giving you guys some layout foundation so you guys aren't super confused once I get into these topics. After you have your configuration object, you use that configuration object to make a connection to Near. Once you make a connection to Near, you're going to implement a wallet connection object, which will allow you to interact with the Near wallet, allowing you to log into your application, sign out of your application, and sign transactions. And then after that, you will create a contract object, which will make a convenient object enabling you to select and interact with change and view methods from your contract you deployed onto your Near account. So things you'll need for just like an app development on Near typically will be like a Node.js, Yarn, Studio Code for your web development toolkit. And then tools that are required would be Near CLI. It's a command line interface that works in your terminal, so you can interact with your blockchain from your terminal. Near API.js to integrate your front-end application to connect your front-end application to the Near blockchain. And then Near SDK RS, AS, or JS. So RS stands for Rust, AS stands for Assembly Script, and JS is a new package we'll be releasing soon to enable smart contract development in JavaScript. And optional again for this particular application I created for you guys, I used React framework and React Bootstrap library to for styling. So the application is fairly simple. It's just an application where I send a message to your blockchain. That message gets stored inside a lookup map in our smart contract, and then demonstrating a change method. And then in this blue little alert window here, that will like pull the message from the blockchain, demonstrating a view method, displaying that onto the page. Very simple application to cover kind of the basic things you'll need to set your smart contract. So let's see. Base. So let's see. From this. Okay, so I already cloned this repo, and I already like checked it out. Yeah, I already like switched the branch that I'm going to be using for this workshop, so it's save on time. See this. So right off that, this should work. Let's see. It's like fail to install dependencies. So yeah, this is the front-end application. So like give you guys a tour of like going into the setup. And actually, give me one quick second. Oh yeah. Okay, so I'm just gonna like create a new essentially. So sorry, this was displaying the finished application. Let's look into. So let's just clone this and then just check it out. Oh, here's I'm sorry. That's it. My apologies, I had to space in my test folder with my actual folder. Okay, so in this folder, you can see we have no Rust smart contract in order to open Start to CD, we got right here, that's good. So we can hard start. Second, just on dependencies. Good, now let's bring our start. Okay, amazing. Log in, pull this up in, you said this. Okay, so sorry about that. So yeah, we have the example application here. You can see this login button doesn't do anything. You can see if the submit button doesn't do anything. So we're going to be looking at integrating that functionality into this application to show you guys how to connect this application to the near blockchain. So coming back to here, I'm going to go over to this HackMD document that I created. Okay, so the very first thing we're going to do is go into our source folder, create a new file called details.js. So details.js. And then I'm going to import these packages, and I'll go over what each of these be like operating these tools I'm importing in a second. So we have connect, contract, key store, and wallet connection. So connect is the actual object that will be used to connect your connect your application to the blockchain after we create a config object. Contract again is an object used to to conveniently interact with the changing view methods of your smart contract. Key stores is used to define the location of your private and public key pair. For browser applications, it'll be stored in browser level storage. And for Node.js applications, it'll be an unencrypted file key store. So you have to specify the actual file location to be able to pull from to sign and send to sign the transaction with the associated keys. And then again, wallet connection is used to interact with in your wallet to sign in and sign up your application and to sign transactions. So first thing I'm going to do is set this variable contract name to activate miami.blockchain.testnet. We'll be creating that unit. After that, I'm going to say, let me copy this configuration object. So inside this configuration object, we got network ID, which is set to testnet. We have our key store, which is set to browser level storage. We have a node URL, define the connection to our RPC, or the connecting to the contract name, which we defined earlier. So this is a count on year. Again, in the count on year, and pull is the actual place that the .login file that your contract gets out to is stored. So we are talking to this contract account to make these transactions to and from your blockchain, or to your blockchain from your application. Wallet URL for our testnet application, we're using wallet.testnet.org. If it was a mainnet application, it'll just be wallet.mainnet.org. Helper URL is just used to fund dev accounts, and the Explorer URL is used to it's a link to our new Explorer. We can view transaction information.
What's the helper again?
Say it one more time.
The helper.
The helper URL is used to fund developer accounts. So you can so with Near in Near CLI, there's just a command called dev deploy. Dev deploy will create a developer account, which is like a randomly generated account that is an actual account. But it comes with fake tokens. It allows you to deploy contracts as many times as you want in the development process while you're building your application. So it funds these developer accounts with about 200 test tokens. If that makes sense. So moving on. So we have our objects, and I'm going to copy and paste this entire function into here. So this function is an asynchronous function that will like essentially set everything to connect our application to the new blockchain. And I'll kind of go over this line by line. So we have this first line here, this variable called near. This near uses that connection object to make the initial connection to the near blockchain with your application. The only parameter it takes is that configuration object that we created earlier. After that, we're going to set a property in the window object called wallet connection. So we're paying a new wallet object in which the only parameter or argument will be the near variable we have here, so the connection object. After that, this window.account ID just returns a string of the account that's currently signed into your application. And then after that, we have our window.contract object, which will create a new contract object allowing you to interface with these view and change methods. So these are the change methods. These are the names of the methods that we have set in our smart contract that we'll build out later. So again, the wallet connection object lets you log in and log out of your application. So we have these two convenient functions that we're going to export from this file, log in and log out. And like I said, it's very simple. This allow you to sign into your application, which creates a function called key pair, which is which gives restricted access to your wallet account to the decentralized application. So again, a function called key pair gives restricted access to the decentralized application to your wallet. The restricted access includes just like a budget for how many transaction fees you can create, or you can call to the user's account. You can it also allows you to specify the methods of view and change methods that the contract account or the user account can call to your contract. It can do more than that too, but I don't get too much into that. So then moving on from there, so that's essentially it for this like connect to near function. Okay. So again, we have our near connection, our wallet connection, our account ID string, and then our contract object, and then these two convenient login or logout functions that we'll use later on. So moving on from here, let's see, I'm going to index.js. So index.js. So when I started this application, I just used create React app. So if you guys are familiar with React framework, it's like Facebook's tool to initialize a front-end application using React. So this isn't create near app. So this is just me implementing it into a raw React environment. So in the come through this index.js page, which is like this JavaScript page, and that creates your initial mount for your app component. The only like modification I'm going to do to this file is first import that function we created in our utils.js file. And then let's see, I'm going to copy this and kind of like wrap this like React.string mode. It's like the mounting of the components with our function. And remember, our function is asynchronous function, so I can use the stop then method to first essentially say first connect to near. After you connect to near, mount the component. Hit save on that. Let's save this. React application. Refresh it. Okay, cool. So no errors, meaning that we're now in the blockchain. I can test it out by saying ID, and which returns an empty string, which makes sense because I'm not really logged in. I can return the contract object. So you have the contract object here. I can type in wallet connection. You can see the network ID is set to testnet. And you can see our key stores here. We have a whole bunch of tools available to us here, allowing us to interact within your wallet. So let's see. See. So yeah, so I think next thing we can do now is implement that login and logout function I mentioned earlier. That will allow us to create a function called key pair again. To grant a function called key to our application. So if I go to app.js and import login and logout from the util file we created. So I'm just going to toss this under here. It's a little bit easier to see. So log in and log out. Going to go to our navigation bar, which is up here. Replace this code, replace the existing code with this. So right now, for us to go to our application, all you need to see here would be the login button, right? So again, this login button doesn't do anything. It's just a login button that has no logic associated with it. So we're going to add in that logic right now. So I'm going to replace this chunk of code with this login. We'll get rid of this and that. So the wallet connection object also comes with this nifty method called is signed in. All it does is return a Boolean, checking whether or not your application is signed in or not in your application. If you're signed in, then true. If not, then false. So I'm saying, is the user signed in? That's what this question mark is. Is the user signed in? If so, run the logout function. That's the other option. If they're not currently signed in, then run the login function. And then this other chunk of code here just checks the wallet connection to get that Boolean. Say if the user is signed in, then use that window account ID variable we created to display the user's account name. If not, just display this string called login. So we can save on that. Refresh on here. So now we hit login. We're going to make this account. In. So I can log in with my testnet account name that I have called blocknet.testnet. Connect. And then if I were to show the nav bar again, you can see blocknet.testnet appeared here. So we know that login button works. Let's see what we have next up here. So next step is actually, writing out our smart contract. So real quick. So I'm going to kind of give you a quick overview of smart contracts on Near. Okay, so smart contracts in Near are written in 3 languages. We have Rust, AssemblyScript, and JavaScript. So you can choose any one of these to write your smart contract. Each of these come with their own SDK called Near SDK RS, Near SDK JS, and Near SDK AS. The typical flow of creating a smart contract and deploying onto Near looks as such. We write our smart contract code. That smart contract code gets compiled down to a .wasm file. Then that .wasm file gets deployed onto a Near account. Remember that each Near account can hold one .wasm file at a time. So then you may be wondering, what happens if I want to use more than one smart contract? So then that's where sub-accounts come in. Sub-accounts are pretty unique to the account structure of Near. So picture you have a mall, and then in this mall you have a pizza shop and a clothes store, and you're the proud owner of this pizza shop and this clothes store. So you own this account called mall.near on the Near network. Only mall.near can create pizza.mall.near for the pizza shop, and then can also create clothes.mall.near for the clothes shop. Pizza.mall.near and clothes.mall.near are 2 independent accounts of mall.near. So that means that mall.near does not actually have any direct control over pizza.mall.near or clothes.mall.near. Each of these come with their own key pairs, their own wall addresses. They're literally their own standalone account. So the owner, presumably the owner of the access key, will be the owner of mall.near as well. But if someone else, we were to give this to someone else, if you're to give the keys to someone else, they would have complete ownership of these 2 accounts. So the main purpose of this is it's good practice to set, if you're using more than one contract, you want to interact with each other in a way. You can use sub-accounts as a means of organization of your contracts. So hopefully that makes sense. I already installed Rust on my computer, so here's the essential command we use to install Rust onto Mac or Linux. and then to add a tool chain so this command essentially adds the WASM tool chain to the Rust environment, allowing it to compile down to that .wasm file I mentioned earlier. This may look a little bit weird. This says WASM32 unknown. What does it actually mean? So you can, in short, without going into like what's happening underneath the hood. The first that means compile on almost any machine or run on any machine. So so again, this first unknown means compile on any machine. This second unknown just means run on almost any machine. So hopefully that kind of clears it up a bit. I'll say to know the way it needs to forecast. So now we can go ahead and create that contract folder, right? So we don't have a contract folder here, so that's going to be doing. We're going to be creating it just from scratch. So I can run cargo new -- lib. Figure for you guys. Call this Miami contracts. So now if I open up my directory, I can see that it's Miami -contract Rust environment. So I have my lib.rs, which comes with this test included, so I can just go ahead and create that. And then this cargo.toml file. You can almost picture this as the same thing as like a package.json if you know JavaScript. I can use this to define my dependencies and whatnot. We'll go deeper into that. So this is how define the or this is how I'll actually include near SDK RS into my Rust environment. So I'm setting near SDK equals 3.1.0. So that's the version of the SDK I'll be using for this example. The .wasm file will copy the name of this Miami contract. So once I compile the Rust code you're writing to a .wasm file, if wondering where the name came from, it comes up here. And I may actually have to go into what these other dependencies are. I guess or curious what these other things are. But for now, I think just pay attention to the dependency here and just metadata. So we can go ahead and actually write our smart contract now. So we can go over to this other HackMD document that I created. Okay, and of course, if you guys want these resources, you guys can find me after this presentation. I'd be happy to distribute it. I'm going to try to turn this into a YouTube video too at some point once I get back to California and have it available for everybody. So I'm going to cover the common crates that are installed that are associated with this Rust file that you'll be seeing a lot in your development. And then we'll also be covering how to implement these crates, creating a structs, creating implementation for your initialization function, and then defining what a view and change method is on here, like I mentioned before. So starting off with these common crates, I'm gonna take this and toss this in here. So we have this first line here called Borsch. So Borsch is an efficient serialization protocol. That's used to send and store data from your contract, from the user to the blockchain into your state. Gas efficient serialization is achieved through Borsch, and you can find more information about the Borsch documentation or Borsch tools here. We have, let's see. Next line here is these 4 packages here are for, I'm not sure what they're called, but I'm just going to call them tools here. So you have env, near bindgen, and set alloc. So what are these? So env just gives you information. Env essentially just gives you information about your transactions. So you can use this to query use the signer's account name, I think the attached deposit value, how much gas they use. You can use this to essentially get general information about your transaction. The only thing we'll be using it for is just to get the signer's account name, meaning the person who called the account and signed the transaction. We have near bindgen, which exposes the, which is a macro that exposes the change in view methods to the user, in short. And then set alloc, which is a boilerplate for a sync and allocator used in the WASM binary. If you have more questions about that, this is the person who actually created that. So I'll leave that to him to answer those questions. And then next up, finally, we have our collection. So this is like, this is a pretty fun topic. It's like if I were to go to here, you can find information about all the collections included in the NEAR SDK. But in short, collections are just data structures that make the data storage onto the NEAR state more efficient. They are familiar data structures that you find in most languages. So for example, we have look at map, which is just a key value pair storage system, similar to what we find with an object or a map in Python, an object in JavaScript or a map in Python. We have a vector here, which is just an array. We have like an unordered set here, which is an array of unique values. So every time I'm like developing a REST smart contract, I want to know like what methods are included with each of these collections. I can go to this resource. I use this resource all the time to see like, you know, what methods are available, like what insert is, like what like arguments it accepts, and like what it returns, for example. So that's all located within this resource. So next up, we're going to be defining our structs. Yeah, so I'm going to attach this micro near bindgen to the struct, and then I'm going to attach these two serialization protocols also to the struct. So this struct essentially is, so struct in Rust is similar to an object in JavaScript. You have a value and you have a key or property and a property value, right? So the property here, you can picture it as records, and you have your property value, which is the lookup map. This may look a little bit weird, but I'm going to find this in a minute. So lookup map, it says lookup map has the key of type string and stores a value also of type string. So if you remember our application, we have a message that we're entering into this form here, which is going to be of type a value type string, and then that's going to be associated with the key, which is our account name that we're using as the associated key to that value. So in other words, this message gets tied to the account name that we're going to be pulling from this environment tool that we have here. So going back to here, we're going to copy and paste this. So this IMPL name here, keyword here, is short for implementation. So implementation is actually how you attach methods to a struct. So you can picture this as like attaching methods to an object in JavaScript, but this is how you actually, this is where you actually define methods for this particular struct. What this is saying is if you're implementing default for Miami contract, again, Miami contract is the name of our struct. Default is a tool used in in a smart contract under the NEAR to automatically initialize your smart contract. If you didn't use this default, you have to create an initialization function for yourself using the let's see, init macro like that, and we'll put something like new some value body of your about all within the implementation. But we're not using that. We're creating our own custom initialization function, so we're using this default tool instead. So then separately from that, this is where we're going to be housing our view and change methods. So our first change method will be set message. So quick definition of view and change methods. A view method reads information from the state of the blockchain, turns that information to the application that you're calling from. This incurs no cost. So like you can call a view method and it will not incur a transaction fee or a gas fee, and so you can pull as much information as you want. A change method adds information or modifies information to the state of your blockchain. Whenever you add or modify existing information to the state of blockchain, you like say if I were to add some information to this lookup map, that would incur a gas fee or a transaction fee. So just a quick little definition of and then let's see, get status. So then now how do I differentiate between a view and a change method in a Rust smart contract? That's what this first parameter here. So this is so at mute self, mute means mutable. Meaning I am mutating the state of blockchain or mutating the struct in a way. And then at self, this ampersand. So ampersand self. Ampersand is just like key character, I guess. I don't know, I don't know what's transfer, but essentially that just means a reference. So it's referencing self. So I'm like looking into the information that's located within this object. Again, so this ampersand is just the shorthand for reference. Similar to states. So yeah, any other questions about like mute and versus just the reference to self? So again, mute self is a change method. Reference just to self is a view method. All we're doing here, by the way, is we're saying for this change method, we're saying let account ID equal environment, and within this environment, we're pulling out this method called signature account ID or signer account ID, which just returns the name of the account that is that most recently signed this transaction. So again, that'll just be the name of the user that's currently logged in who called the method with the signifying method. That account ID again is used as the key inside OpenMap to the associated value, which is the message I'll be sending to the blockchain. I'm using this insert method, which you got from that collection in that resource document that I showed you guys earlier, to then insert this key value pair into this location. And then today you have self.records, which is how you pull out this property. So hopefully that flow kind of makes sense if you're new to Rust. And then this view method, let's see, turn this off. So this view method just simply returns the value, which is the message associated with that key account. So we're passing in the key name as we're passing the account name as a string as an argument into this get status function that gets passed into here. Notice this ampersand, or notice this reference to this parameter. So you have to include this reference to this parameter when you're relating your arguments to the body of your function. And then this .get method again is another method that's included within this lookup map, which will then return that value. So again, hopefully this makes sense. So now this is actually it. This is our entire smart contract. All that's left now is to actually compile it. So I'm going to run this. I'm actually going to set this up for you guys. So I'm going to say cargo bill. Actually, first cd into our contract folder. Say cargo bill dash target awesome 32 unknown dash unknown, and then dash release. So that's all included here. I forgot to save my tunnel file. I literally always do that when I test this. There we go. Filing. Okay, so we're almost done. So if I go to target to WASM 32, I'm going to try and make this a little bigger for everybody. Go to release. You can see this Miami contract.wasm file. So it compiled successfully. So now all it's left to do is to create that sub account that I mentioned earlier, and then deploy this WASM file onto that sub account. And then after that, we're going to implement these methods into our front end application. So let's see, I'm going to create this account. So I'm going to use near CLI to create my sub account. From my sub account will be called activate Miami .blockhead.testnet from the master account blockhead.testnet, sending initial balance of 30 NEAR or 30 test tokens in this case to that newly created sub account. So I'm just going to paste that here. Then go back into my utils folder. Let's see. Don't forget. Just one. Save. So yeah, now we've created our new sub account. And again, if I were to go to Explorer, I can like even view that sub account, but I don't do that right now. Let's see. So then now to deploy that WASM file onto that particular sub account that we created, I'm going to say near deploy -- account ID activate Miami blockhead testnet -- WASM file -- WASM file. Go to my target, going to go to my WASM 32 unknown, but going to go to the release folder, and then luckily that's it's nice that the terminal has some green for me, so I know which one to choose. I'm going to hit enter. So now it's deploying that .wasm file onto the sub account. So I can check out that transaction in your Explorer. I want to, so you can see that it succeeded, so that's good. Get some nifty information from that transaction here. Close that for now. Close this. So now we have the contract successfully deployed onto that sub account, and all that's left is to finish up this document by implementing these methods into our application. So I'm going to go over to app.js, bring this down, going to pull this over here, just this. Go here. So I'm going to use this use effect React hook to essentially get our message, pull that message from the blockchain. This React hook essentially says, once this component's mounted, run this get method function once. So it's going to run it once upon mounting the component. So all we're doing, and one more thing. Any smart contract method you create, view change methods have to be added to that contract object. So we are exposing this to the front end through this contract object here. So just want to quick plug for that. And then to actually use those methods, every contract call you make to the blockchain has this asynchronous process. You have to create an asynchronous function. And I'm saying you have to attach this to wait keyword to wait for that promise to resolve. So we have window.contract.get message. Then you have to get this message, you have to create an object instance. Within the object instance, you have the property name, which is your account ID, and the value, which is just a string. So this, if I were to type this into that terminal here, again, I get account ID, which returns blockhead.testnet. So actually, I should just, for good measure, I think should be up. No, I can never go up. So blockhead.testnet. So then save that. And then the other function we want to implement is our submit, the one for our submit button. So we can copy this and paste this in here. So this submit button is attached to this button here, which will submit the value I write here to the blockchain into our lookup map. So I have submit, await window.contract.set message, the value will be the message, which will just return the value that I type in here, send that to the blockchain. Once that's done, an alert message will appear here telling me to refresh the page. So then remount that. So I'm going to uncomment this from this button. So on click submit, save, to run, yard start. So yeah. Status. Yeah. Status. Sorry, wait, one about for today. Okay, cool. So now if I type in puppy, submit button to do this transaction. I think I have to relog in to avoid doing this. Let's cancel. Sorry, say all the time. I've sent this here. I do have sent this. Sent message. Okay, so let's hopefully try again. So log in for application. That's where it says we can log in, connect. Look at the testnet, try this again. So puppy, hit submit. Logged in now, so we're going to have to get redirected. Please refresh the page. Refresh, and now I have puppy here. So yeah, that's it. That's our that's the demo application for you guys. If you guys have any questions, you guys can feel free to find me anytime. Really take over.
All right, hey everybody, I'm Will. I used to work here, now I work at AHA Labs where we make AHA moments for you. So I'm going to show you one thing we've been working on. So, we spent first good bit going over the front end code. The tool that I've been making helps you sort of skip that process and get right into playing around with the app. So I'm sure, how many raise your hand if you're familiar with ABIs on Ethereum? All right, basically just the API of your contract. So you're not telling me where it is. So
I don't know what it means, application.
binary interface.
Binary.
Yeah. So we've been making one from here. We call it application contract interface. Makes a little more sense. And yeah, I just got to figure out where on his machine. Sorry, it's the folder that we made this. All right. And it's a download. So the tool is called Rain, which is near backward. So easy to remember. So all that stuff, the ceremony that you had to go through when you were compiling the Rust, you don't have to worry about that. So it'll do is it'll compile your Rust. So I'll just here we go. So if I now do Rain build, where are we? We're in 3. All right, so I made a couple branches here. Let's go back to the first one. Feet/rain. That happens to me more often than I admit. So now here, dash. Rain. So first let's look at the contract, actually, just real quick. So it's very similar to the contract that he just had, but I just wanted to highlight, not just having strings, but something big, different. So here is actually also this new type called account ID, so it's not just a string. Then we also have this new type message, which has a title and a body. And so if we can see now, our contract looks like this. We have set status message, where we take a title and a body, and we have get status message, which returns a string, and it returns a JSON string of that title and message. All right, so now when I do rain build -- release, actually I just do yarn build, so this will have the types injected into the WASM itself, into a custom section, and it outputs it to this location here. So now, let's see, we have a, so Marvin, So he created a sub account to create a new account to deploy to. You can do that, but there's also this handy dev deploy that he also mentioned. So if you just do yarn, and I just have yarn do it, yarn script to do it. And so what it's going to do is, it's going to call this dev deploy command, which will create a random command using that helper endpoint, and then it's going to deploy the contract to that account. And so in one step, we have this new account, and it's been deployed. So now I can copy it. So it's just this long dev, it's like a timestamp plus some random amount of bits. And there is the admin page. So go rain dev/admin. We can then copy that into here. And so what this is going to do is going to pull down the WASM. There's an RPC call to get the bytes for that contract. And then it reads the contract bytes, finds that custom section, and then we can now look over it. So we have the view methods and change methods outlined. So again, we can just skip all of that ceremony before, we can get right to the contract. And if we go first to, let's go to the set status message, you'll see here that in the set status message, we have this comment here that pops up right there. And so now we can try to do something, let's say A and B or not. And then now here you could attach money to the call, but we don't want to. And then now we're going to also say use as much gas as possible. Hit submit. Oh, I'm clicking on the wrong thing. There's a thing hovering over the. Okay, so approve that transaction, and it's going to take us back. And then now if I go to get status message, so it doesn't pop up right away like this did, but now, boom, there you get it. So there's that JSON string. But that was it's a little annoying because we had to, in our function here, say what the title and body, all these internal types we had to expose because they're strings and we already know how to deal with strings. But now if I do the checkout rain 2, what this looks like is that now here. Actually, I have to update this. So we can do, well, first, actually, this isn't going to work. I just wanted to highlight. So here's message again, but now when I try to, when we return message here, what that does is now we're exposing this type that we defined to the outside world. So when I try to compile it again, it's going to get mad. It's going to look over the types and it's going to yell at you and say, hey, this option message, I don't know where this message type comes from. And so it even has this little helpful message that says you need to use this thing called widgen. That's the thing that generates these types. You have to add it as a dependency and then add that as a macro to your type so it knows to then go and define it. So we can then skip having to do that because I already made another branch for it. So here's the third branch. So as you can see up here, we added this little widget to it. And so now it'll know what a message is. And then as you see here, I can now use message as an argument for my set message so that I don't have to then define all those individual fields. And then again, here I can return a message without having to, go through the process of making that string. So now what we can do is we use the dev deploy again. It saves that account to the local, to a folder in the local project. And so instead of creating a new account, it's just going to redeploy this contract again. And we can go over here. Now, if I just refresh this, and we'll see that now it's now returning that as an actual JSON as opposed to a string JSON. And then if we go over to the set methods here, now we get all the fields that are required for a message type, and it's going to then encode the message and send it over. And in fact, the comments that we have on the fields, like here, show up here to help you describe what you're argument. So this way you can focus on just writing the contract. You can write all the comments in the contract will be able to be reflected immediately in the form, and you can iterate fast, and you can create, you don't have to worry so much about all the ceremony of the web page, and this stuff can also create TypeScript for you, so you don't have to also deal with the handcrafting with all of the methods under contract. So I'm excited about it. It's called Rain. Any questions? I kind of went fast there. How much time did it? Oh yeah, shoot, I have 30 more minutes. I didn't have to go as fast as I did. So yeah, sometimes we can do some fun stuff here. So one of the things you can do is, let's say you want to make title always start with title. So I can go, let's see, I think it's pattern. And then you can use a regex, or I can say title. And now if I save it and then submit it, what the form will do is now validate if you have that as part of your string. And this is really handy because you showed me your account IDs. They're not like your normal long string of base whatever encoded public keys are. And so because of that, now there's a regex that defines what an account ID is, and then now we can check and validate that it's a proper account ID instead of having it fail when you check on the chain. So let's go back over here and let's refresh it. Now so body, we just keep that here. If I do AA here, let's make it easy, whatever. Now, fingers crossed it should fail. Yay! Okay. So now it's saying it failed because it didn't start with the word type. It's not the best message for your end user because they don't know regex. But the point is that it's gonna, you can add these little comments to your types to be able to, validate it before it reaches through your contract. Yeah.
So you compile the comment.
It's left.
You compile the comment.
So the comment is ignored by the actual bytecode that's sent to the chain, but the type that comment is embedded into the type file that's included in a custom section. So you pull down the binary, and then inside of there it sees that's a thing that can actually. So now that we have all this extra time and you asked, we can see what it's actually doing under the hood here a little bit. So in the target directory, you have this width, and I won't get into that, but basically this is what it generates initially, and then from that we get the JSON. So WebAssembly itself will eventually use this, what's called WebAssembly interface types. This is a sort of a polyfill for it until they have it as part of the actual standard. And so as you can see, it looks a little bit like Rust or any kind of type language you've seen, like, this is called a record instead of a struct. And then here we have a function, and it takes a message. And here's how I tell it that whether it's a change method or a view method. Basically, if it doesn't have change, then it's a view. And then if we scroll down, we can see, here's what an account ID is. Actually, let's do this. All right, there you go. So here, I'm not going to try to parse through this regex because it's not worth it. But here it is, and it has a minimum length of 2 and a maximum length of 64. And so that gets encoded into what's called a schema JSON file, similar to a the ABI file on Ethereum, but it's more general purpose. So as you can see, here's account ID, and here JSON itself, the schema JSON has an idea of validating JSON. So it basically just describes what it can't be. And so here it's a string, and it has to match, that pattern, have that minimum length, maximum length, and then that's what the form over here is automatically generated using that. So if we go down, we can scroll down here and see, here's the call options, which are down here, cash, deposit, and gas. And then where is so here's get status message. Here it says it's a contract method is view. There's that description, and then the properties being the arguments that it needs, which is account ID of who you want to get the message for. So Yeah, that gets compressed using Broadly, and then on the front end decompressed. And funny enough, this tool actually makes your contract smaller. So if I do ls or ll, WASM, let's see here. So the long one here with the target release, that was 112 kilobytes, and then the one that I popped out for me was 104. So somehow adding more bytes and during that process of reading the bytes and shoving them back in saves some space. So yeah. So yeah, this is sort of a soft launch of Rain, but if it's rain.dev, if you want to check it out, rain.dev/admin. Actually need to add the link to the main page of it. But yeah, so soon we're also going to update the full UI for it. Right now, since there's only 2 things right here, it's okay. But if there was a long list, then it gets messed up. But yeah. So soon it'll be easy to add, you could, in your project, depend on another contract, and it'll automatically generate the TypeScript for that contract so that you don't have to go hunt down where the source code of that contract is. And yeah, so any other questions? All right.
All 4 skipping steps, so good job.
So yeah, and one other thing that we've been doing with it is adding, you can right now just make a comment about the permissions on a function. So you can make it like an admin, and then you would have like an admin view method to see which accounts are admins, and then it would check to see if your account's an admin, and then either prevent or show you these methods. So yeah, there's lots to do with it, and it's at that stage where it'll be a lot of stuff moving fast. Anyone, anything else? Any other Rust related questions or near related questions?
We had this function, you submit actually any weight.
Mm-hmm.
So you await the SQL returns awaiting the transaction.
Yeah.
Second, what will it? We wait until the transaction is set.
You guys speak a little louder.
Yeah, I was saying that maybe if you open
This
somewhere
right
right
side
your
up.
application, there's a button when you send a message when you send a new value.
Yeah.
Oh, sorry, that was for another demo.
Oh.
Sorry, that was for the demo. If you made the demo, right? When you the application, when you set up a new value, when you click the submit button, the enter, right, has the logic of await. You await, so now you are waiting until the transaction is actually submitted. Yeah. Or you're waiting until obviously all is finished.
So you're second. So you wait till it comes back and you feel whether it succeeds or fails.
And then you have to wait until the transaction is submitted.
Completed. Yes. So unlike say Solana, there is gas so the more gas that I include in my call, the more likely my transaction is going to get scheduled. And so the wait time's not so bad. Is that what you mean?
So that's like by the time it's finished, the transaction will be already on chain, right?
Yeah. Yeah. So when it updated Puppy, that was from the view call. So it returned from the transaction and then made another call to get the value.
Can you show an example how to interact with
How to interact with contract?
yeah, how to interact from the contract with another one.
Oh, you mean that? So cross contracts. Yeah. So we can maybe pull up an example. So let's see. Is there one on your examples?
Yeah, so I think I feel like so
I can show you one that a contract that I wrote. It's going to be a little bit more complicated, but it should. Yeah, so the way that we the way that you declare an external interface is right now you have to do the trait. So the stuff I've been working on will automatically generate this stuff. You can say I want to generate the code for X contract and then go ahead and handle it. But right now you have to do it manually. So here you so this contract is actually on. So as we mentioned, you have every account can also have a contract. So on testnet there is a testnet contract, and that's how you would create a sub account. You would call testnet contract and say, I would like to create an account with this ID, this sub account, and here's the public key to associate with that account. And so this method, create account, if you're on testnet, you would be calling the account testnet, and if you're on mainnet, you would call near. And so this, I won't get into the full details of this contract, but what this allows you, what you can do is basically reserve you can register with my contract, this one, a public key, and then somebody else can come and later claim using the private key to create an account. So it's a common way to onboard new people, which you can send them a link, including the private key and the thing, and then they can create in wallet a new account. And so we actually then, if I search this, yeah. So that trait then becomes this, has a macro on it, becomes a new module, and inside that module you have functions that will handle all of the ceremony that comes with registering. So that EMV package or crate that he talked about, or modules, it contains the stuff you need to make that contract call. And so this is a handling all that for you so that you don't have to do it by hand, but it's still saying that I would like to create a call to this address. So right, that's why it has this edit function, because it'll check. If I'm on testnet, it'll get testnet. If it's on mainnet, it'll get near. And then you're going to pass in those two arguments like we saw above. And then here's how much it costs to, because when you create a new account, you basically have to pay to store that unique name on the chain, versus like an implicit account, which is just a private public key, or the public key, which is free. And then here is how much gas you want to put towards that cross contract.
How do you handle the return from this function?
So that's the question. So this create account returns a promise. So it's returning the reference to that thing that's going to happen. But right now it's just an ID of it.
That's always the case, like if you're calling to external account, that's always, you can always get a promise, or just that specific.
So under the hood, what you're doing is creating a promise, and you get an ID that refers to what that promise will be scheduled. And so if you go to above where we had, again, this isn't the greatest example because it's my contract, but this is returning that promise. And then, so you can say, there's this, again, this is a different promise. Don't worry about that. But basically you can say there's a promise, and so I want these two promises to happen. I want these two calls to occur. And then after that, call this one, link callback. And then call that external one again with the final one, because it wants to make sure that your thing succeeded. So it's a long chain of things that come, but the tricky part with near versus other cross-contract calls on other blockchains is that they're all independent and atomic. So the first one, this initial call that we're making, it will finish, and any state change that you made during that will be done. And then you have to, but then you can then, after the next call, check to see if that one succeeded, and then you can roll back. But you have to manage all that yourself. But it has an added benefit. Let's say like on Ethereum, for example, if I make a cross-contract call to mint an NFT, and I look at the NFT I get back, I can decide if I want to just cancel the whole thing and roll back the entire chain of promises. But on Near, when I make a cross-contract call to mint an NFT, when I get that call back, it's already been minted. I can say cancel this current call, but the previous call hasn't occurred. Any other questions? All right. My computer's special. We got 3%. Yeah.
Can I have the screening link for this session?
What's the schedule? What was the question?
Schedule this
Streaming.
Oh. On each like cell, they have for each session.
Yeah. Hey, everybody. How's it going? Cameron, good job, guys. Work at the Year Foundation. Just want to make everyone aware of some opportunities in the ecosystem. So we have Near University. If you're interested in learning more, just go to near.university. There's a bunch of self-paced courses where you literally learn everything. And actually, Dorian has daily office hours on Discord. So if you have any sort of like technical questions, you literally go on Discord every single, at least Monday to Friday, and he will answer your questions. It's pretty cool. I don't know if you guys ever get any type of support like that anywhere else, but it's pretty awesome. So there's that. There's Near University there's three courses. One's for developers, one's for entrepreneurs, and one's for analysts. So if you're at all interested in like getting into the space, it doesn't really matter your background, there's something for you. There's also a ton of jobs. If you go to jobs.near.org, there you just see everything out there. Right now, we're actively hiring for more developer relations experts, similar to what Dorian and Willem are doing today, just coming up and chatting about interesting technical topics, doing technical support. And there's also a pretty awesome grant program. It is slowly, markets are going down. So there's not as much, I guess, support for, like for-profit companies. But if you're building open source tools, there's plenty of support for you. Even if you're building a for-profit company and you just want to open source it, we're also happy to support. So come talk to me if you're interested in grants. And there's also if you're based here in Miami, we host about like almost bi-weekly workshops. If you go to Near Miami on Twitter, you can start seeing everything that we run. It's about every 2 weeks. We have like some technical workshops, non-technical workshops, social events, and throughout the rest of this week and weekend, we will be having a Near Hacker House. It's about a mile away, and it's where the co-founder of Near, his name is Ilya Bolasukin, and the CEO of Aurora will be coming tomorrow, talking about what's super new and exciting that's happening in the ecosystem. That's going to be pretty much around like 12 p.m. But tons of food, awesome events. If you're looking to learn, get a little deeper around certain topics. For example, yesterday, Jordan over here, he is the product manager of Astro. Astro is the DAO framework for Near. He was walking through the different contracts and sort of what the new Astro framework is. And so if you're interested in more vertical specific education, come on by, and there's a lot of opportunities for you. So yeah, feel free to reach out to any of us. We are pretty much Near core people. And
if you're interested in NFTs, I'm giving a talk on Saturday.
Yeah. So yeah, thank you.
Is that tomorrow here or over there?
It's over there. Yeah.